I have my checking jig right here. Doesn't hurt to double check if you think there's a problem. I checked on one of my other holes to double check a number already once earlier. And I was off by 30 thou because I was reading the wrong number. Good thing I checked. Lower. And we'll come and double check again. Seems like we're all right on this side. My guess is the hole going through this D-ring is going at an angle, not square, which causes our hole to be off on the bottom. That would be my guess. How does the drill go through it? And that is what is going on. Yes, I'll show you so you can see what it is. So you take a shortcut and look at the problems we run up. I don't know if you can see it or not, but if you look at that drill, it's leaned over to the right side. Pull back a little bit, you see better. It's actually leaned this other way to the right. And straight is actually more this way. That, when I push it and flex it, that's straight. So you see how it cocks over? So this hole here is drilled at an angle. That's why my tap was going at an angle. So, little problems you have. So that Harley D-ring isn't that good. Let's see, get this back where I had it over here. There we go. So I'll have to compensate for it. It's always nice when you have problems. Go ahead and mark this hole so in the future I know it's off. Whenever I put a red circle around something, I know there's something wrong with it. Probably not just that one either, but there's probably more. That's why they have big holes in these covers so everything fits together, even though the alignment's off. Alright, so what I'm going to do, since I already drilled a hole, I don't really particularly want to tap at an angle, I'm just going to go ahead and kick the table over toward me about 10 thou to compensate. And that looks a lot better. So you get about 10-15 thou air in that thing. Alright. have a slight high spot on the thread. I don't like high spots. Just knock off the top thread here with my round tool here. Deburr it. There you go. Okay, we've got our heater coil in here. Trick is to make it follow the thread you want to. So you let it find its thread. If it doesn't go in right, if it goes really hard, back off. Like the first time I backed it off, this time it went in. So go ahead and screw this down. That's flush. I go another half a turn or a third of a turn there. Pull it out and look at it. Dark under there. About a full thread up. So I'll go ahead and get this thing to full half a turn down. Right there. Below my surface and I'm good. And I gotta knock that tang off. Just take a little small screwdriver, you put it at the base of the tang, you knock it off. Now you can do it from the top side like this or from the bottom side. Either way it does work. If you go from the bottom, it will never pull the heater coil up. If you go from the top, if it's not in the first thread real good, it'll push it out the bottom. So I'm going to do it through the top, because it's not a problem. You pop it like that, and the tang, I heard it hit down here on the mat. But you always want to make sure you find that tang if you got any kind of motor part apart, because you don't want that tang inside your motor. So you always got to go hunting for them, is what I usually do. And I throw them away. This piece of hardened stainless, definitely want that in your motor. I don't see that one, but being an open motor, I'm not going to worry about it. So here's our screw that we're going to use. So it goes in half a turn of stops because of the locking action. And you can see how tight the locking action is. If it was a regular heater coil, it would go straight in, no problem. More leverage on this. So you can see how much pressure it takes to overcome the locking action. So when you go to assemble the motor, you'll have that same problem. That also means it'll stay tight too, which is the part I like. So there it is, it's in there. So we'll go ahead and do the other two the same way, and that'll be that. So we'll leave it at that for now.